Okay, you can start.
Yeah. A very good morning to all the participants present here. A heartily welcome to all of you for our ACM DSP talk of the day from our eminent speaker, Ricardo Baeza-Yates. I would like to give a short introduction about our eminent speaker of the day. Ricardo Baeza-Yates is a research professor at the Institute of Experimental AI of Northeastern. He is also a part-time professor at University at Pompeu Fabra in Barcelona and University at Seychelles in San Diego. Before, he was a VP of research at Yahoo Labs based in Barcelona, Spain, and later in Sunnyvale, California from 2006 to 2016. He is a co-author of the bestseller Modern Information Retrieval textbook published by Addison Wesley in 1999 and 2011 that won the ASIST 2012 Book of the Year award. From 2002 to 2004, he was elected to the Board of Governors of the IEEE Computer Society, and between 2012 and 2016 was elected to the ACM Council. Since 2010, he is a founding member of the Sherlin Academy of Engineering. In 2009, he was named ACM Fellow, and in 2011, IEEE Fellow, among other awards and distinctions. He obtained a PhD in computer science from the University of Waterloo, Canada in 1989, and his area of expertise are web search and data mining, information retrieval, bias and ethics of AI, data science, and algorithms in general. I heartily welcome you to the talk, sir. We are looking forward for your speech, and the screen is yours.
Thank you. Thank you for the presentation and the introduction. So the topic of today will be about big data in relation to machine learning. So I'm part of the Institute for Experiential AI that is based in Boston, where Northeastern has its headquarters. But I work on the campus that is in the Silicon Valley. So we have two in San Francisco and San Jose. So, and as you know, this talk is thanks to the Distinguished Speaker Program of the ACM, and you are a ACM student chapter, so you must know about this, but you can find more information about ACM in acm.org. It's the largest computing professional association in the world and has more than 100,000 members, most of them outside the US. So this is what I want to talk today. It's a little bit about the opportunities and challenges on big data and machine learning. And the challenges I will focus like scalability, noise, bias, sparsity, and legal and ethical issues. And one important topic that will appear is what is called small data, not big data, and you will see why. So before I start with the presentation on big data, let's talk about big data and predictability. And let's say you have complexity in the vertical axis and size of the data in the horizontal axis. It's not too difficult to take a set of images of myself and then do a classifier that will recognize just me. So basically distinguish me from other people. However, if we have something like Einstein formula, that applies to any basically object in the world. So after you know the formula, that you can think is a larger scale formula, applies to any object in the universe. Then you have things like, for example, very complex, not too large, for example, the stock market. But if the stock market will be predictable, maybe the stock market will not exist. And then you have things more complicated. So this is one of my favorite paintings, is the Garden of Eden. It's by Bosch, a Flemish painter. And basically here there are very weird animals. And to basically classify these animals based on, for example, standard animals would be very hard for any classifier unless we do one that is particular to hit this type of painting. So cannot generalize. And of course, this is a hard problem, but also it's much larger. So one way to talk about big data is to use this taxonomy of the 5 Bs. And I include in this taxonomy 3 different issues that can appear. The ones that are data issues, the ones that are computing issues, and then the last ones that are human issues. So you have volume, variety, veracity, velocity, and value. So very important, if there's no velocity, it's really not big data. So big data has to be a stream all the time. It's not just a big file in a disk. And of course, needs to be right data. I will go back to that. So true data, and that has to do with veracity. And of course, has to have value. If it doesn't have value, then really is not very useful. And I will not read all the issues, but for example, in this talk, I will focus on the red ones, like in data will be bias, sparsity, noise, privacy, very important. In computing, only one, scalability. And the human issues is again bias, privacy, legal, ethics, also bad practices. I don't think I will have time to explain that. So I assume that you already had a course on machine learning. I hope so. But let's talk a little bit about history. Why we have this hype on deep learning? Well, the reason is because we have more data, we have more processing power, like with GPUs, and also we have the ability then, with more data and more power, do many more layers in neural networks. Neural networks are very old, like more than 50 years, but now we can do very deep networks, and that's why it's the hype. And this can be applied to many different things, and we see that every day. For example, in your cell phone, you have that power. So the typical machine learning that is used in these cases is what's called supervised machine learning. So you train with a labeled data set a model, and then you run the model. Here it is a rhomboid. You run the model for predicting, for example, what is the animal or what is the object in a new document or image that you have never seen. So you have to cross your fingers, because this is a prediction. It doesn't work all the time. Now, what are the opportunities? Very brief. So you can really do data-driven decisions. You can do global optimization. So look at the big picture, which is hard for people to do. You can learn, you can predict, and also you can prescribe. So basically, if you can predict, you can avoid problems in the future by acting on that prediction. You have all the problem of machines deciding for us, what is called automatic decision making. This is one of the main problems today in AI, because basically you have bias. So we'll mention this again during the talk. And then the impact, the negative impact, harming people psychologically or physically, could be very relevant. Here, maybe the best example is what happened last February in the Netherlands, where the whole government had to resign because of the result of a faulty fraud algorithm that accused 26,000 families that they were cheating on childcare benefits. And of course, that usually is the poor people that suffer the mistakes, not the rich people. Now, we need to ask the right questions when we analyze data. And here's a list of questions that are important. I will not go over all of them, but remember, it's not the data we have, it's the data we need, which not always is the same. How we can collect it, how much noise, how much bias, outliers, redundancy, things that you need to ask. Privacy issues, scalability, visualization, and remember, garbage in, garbage out. So if you have bad data, doesn't matter how good is the algorithm. So what are the challenges? And this will be the main part of my talk. Here you have this joke from Calvin and Hobbes, where you see that the kid is basically lying just to mess with data. Sometimes it's good to do that if you don't want to be predicted. But one problem with data is that we know only the successful data. We never know, for example, the failures. For example, we could learn from failures, but that data is never published because people is, I guess, ashamed to talk about failures. So let's go for the first challenge, will be the only computing challenge. And the problem is how to scale. In the best case, you need to read the data. So if you double the data, that will double the time. But most of the time, the algorithms are not linear. For example, training algorithms are not linear. So it would take more time. One way to smooth that is what I call a time complexity versus a result quality trade-off. Let's say we have this problem could be, for example, entity detection. So Q is the quality, it's in the vertical axis. And then you have the size of the data in the horizontal axis. And let's say you have two algorithms, A1 and A2. And you see that A1 is much better because it gets more quality. However, that doesn't say anything about the time that needs the algorithm to achieve that quality. So imagine that A2 is not so good in quality, but it's much faster, and that's why it's not so good. So there's some point n star where at the same time t star, A2 starts to be better than A1. Basically, you trade quality by time. Why? Because if the algorithm is faster, you can process more data, and then with more data, you can improve. So basically, here you say, okay, at the same time, A2 is better after some point. So you have other trade-offs, like, for example, downsampling versus quality, the same issue. You have things like map reduce, not always working. So you may need to do a different distributed parallel processing, because parallelism is problem dependent. And for also online processing needs a different approach. So there's some intrinsic parallelism depending on the problem. For example, graphs don't have much parallelism in many problems. Anytime that you have to optimize something global, the parallelism is not so good. Next challenge, noise and spam. The noise may come from many places, like the instrument that measures something, for example, could be sensor data, so that would be in the world of Internet of Things. Also, the noise may come from how we interpret the data. And spam is everywhere. So spam is, for example, will be like email spam, will be like a web spam, basically information data that is just created to deceive us. And one way to fight this is what is called the wisdom of crowds, but not always is possible because sometimes the crowd is wrong. For example, imagine that you have the majority of censors saying something that's wrong. You will believe that it's right because it's the majority. So this is one problem of democracy, that the majority rules even when it's wrong. So redundancy and bias. For example, are there dependencies in the data? There is any duplication. For example, the lexical duplication in the web is around 25%. You will see later in example that the semantic duplication is much more. Biases, well, many. You have data bias, you have activity bias, I will mention what is that. You have algorithmic bias. So this is algorithmic bias for me, is when the algorithm adds bias, not coming from the data. Not always the data is the source of bias. And finally, we have what I call interaction bias, which is the feedback loop between the system and the user, and I will talk with more detail about this. So it's very easy to learn racial bias from data. Here you have an example from the UK, where you see the population of white, black, Asian, mixed, Chinese, and other. Here you have already a problem because Chinese are also Asian, but I guess Asian here in the UK means from India and Pakistan and Bangladesh and Sri Lanka, so the Indian subcontinent, and they put the Chinese in a different class. Part of the problems of bias come because of using categories that are not correct. For example, this one is an example, and you know, race is a social construct. We can use any characteristic of people to divide people, and that doesn't mean it's right. But here you see that the bias is against blacks. So, for example, maybe only 5% the population, but then you have more than, say, 15% of the people going to prison. And let me give you an example where bias is not only captured, but also is amplified. So this is an example that comes from an analysis of bails in New York. And in New York, this is the state of New York, 18% of the population is Black, 13% is Hispanic, 32 is the sum of these two. However, the defendants that get to court to see if we give them bail or not is in total 82%. So there's quite a bias on these minorities, and especially for Black, like almost 50% are Blacks. So now the judge is racist. You can see that the percentage of Black increased from 49% to 57%. So 57% of the people don't get bail. And in total, it goes from 82% to 89%. Now, in this model, that is a very interesting paper by Kleinberg et al., they only use the age of the person, nothing else. I mean, as a demographic. Of course, they use all the information of the case. And what happened? Well, when you look at the model was a bit more racist than the judges. So it went from 57% to 60% for Black. But it still was much better than the judges. That is, they could decrease the crime rate by 25%, sending the same amount of people to the prison. And the reason is that basically the decisions of the model seem much more correct than the decisions of the judge. So the judge is noisy in the sense that judges to the two similar cases, sometimes they give different results, different outcomes. And this is a problem because here we have a dilemma. And here you have all the cases, exact, noisy, bias and noisy. What will be better, a bias algorithm or a noisy judge? So the bias algorithm in some sense is just because for the same case always gets the same answer. It's deterministic. A judge is not like that, it's noisy. So for the same case, may answer something different. Of course, the judge is also racist, we have seen. So basically we have the judge is more close to D, while the algorithm will be close to C. This month, Daniel Kahneman has published a book called Noise with two colleagues about the large loss of many kinds because of noisy decisions. That is a big loss, not only financial, but also social when we do noisy decisions. Let me show you an example of gender bias in content. So these are biographies of women in Wikipedia. You see that they were going down until the French Revolution, and the French Revolution they were going up, and now we have almost 24% of current women in Wikipedia. You can say, okay, this should be 50%, and then you can say, okay, this is just systemic bias. But the truth is that there is another bias here much more stronger than systemic gender bias. And this will be obvious after you know it, but that's all obvious things before is not true. So most editors in Wikipedia are male. So for women, they are like minorities. For example, for people, it's only 11%. And these numbers are also biased because you are not forced to give your gender in Wikipedia, and many women prefer not to do it to avoid any kind of harassment. So this number may be 15% for people, but we don't know exactly because of that. So we have partial information here. So what is activity or engagement bias? Well, the idea is that, let's say we want to know which percentage of people generate half of the content. So this circle means that for a Facebook sample, 7% of the people did half of the post, and 93% of the people did the other half of the post. So we did the same for Amazon reviews, and here we found that 4% of the people did half of the reviews. So this is Diego, one of my PhD students, said this cannot be right unless they are being paid. And 1 month after we published this paper, in September 2015, Amazon started to sue fake reviewers. Basically, they were getting paid to do false reviews. And until today, you can go and find news about fake reviews. We did a bit more. We trained a classifier based on text entropy that we found that had a high correlation to the number of stars of the review. So we used that as proxy, and the 4% was reduced to 2.5% if you take the best reviews, not half of the reviews in volume, but the best reviews. So basically, if you take the best half of the reviews, then only 2.5% of the people did that. This is related to what Nielsen called in 2006 the participation rule. You have 1% that do things, 9% that comment or put a like on those things, so 1% influencers, 9% that comment on them, and then 90% that are lurkers. They just look, they don't do anything. And if you think that's the case on many social media. For example, in Twitter, 2% of the people do half of the tweets, and 98% of the people do the other half. So very, very biased. And in Wikipedia, you may not know, but 2,000 people did the first half of English Wikipedia. And maybe thanks to that, we have Wikipedia today, because nobody contributes to something that is empty. You need to see it at least half full. And with Diego also, we look at other problem that I was interested is how much content in the web no one ever sees. Here we found that if you take all new content and additions to Wikipedia in 1 month, 31% of the articles were not seen the next month. That would be like an upper bound. A lower bound, in the Twitter data set, we found that more than 1% of the people do not have followers. So basically, 1% of the tweets cannot be found because those people don't have followers, so they will not appear anywhere, because if you do a search, even will be too low in the ranking. Let me give you my best example of algorithmic bias. So let's say you have a system like Flickr, where you can upload pictures and put tags. So here's a picture of London, and I put the tag London Eye and Thames. And then I do, because I'm a computer scientist, I do a nice tag recommender system based on co-occurrence of tags, and can recommend tags to the people. What is the problem with this system? The problem with this system is people will use it. So next time I will put only one label. Why putting more if the system is giving me great labels? And if I'm really lazy and I know that they are doing deep learning, they say, why I will write a label? Let the system give me the labels and I will mark the right ones. So this is the problem. The system cannot improve if it doesn't get data from people. So the system cannot learn any longer. So if you have a taxonomy, basically labels coming from people, you cannot help people. You don't need to help. You can use this recommended system to do like query expansion and find more things, but you shouldn't help people labeling, because otherwise you will not get more labels. Bias in the interaction. So you must know this page. This is a very common e-commerce page. And the first bias is called presentation or exposure bias. You can only click on things that are in this page. You cannot click on things that are not in this page. So you are exposed to only some objects. So the system is partly writing their own future. Then you have things like position bias. So like in the Western world, you look first at the top left, and then you read from right to bottom. You have also the problem of ranking bias. So people click more on the first choice because it's the first choice, and then search engine have to mitigate or de-bias that, because otherwise they will fool themselves. And then you have social bias. For example, you may see the reviews, and based on the reviews, you may take a decision, but then other people is influencing you. And finally, you have interaction bias, like, for example, do you scroll or not? And this is a cascade of biases. You see here different biases. The ones in the left come from the data and the algorithm. The ones in the right come from the user. So this is the feedback loop of the biases. And you can read about all the biases on the web on this paper I published in 2018 in Communication with ACM. But here you have all the biases that I mentioned before. So activity, sampling, we didn't mention that, but it's also important. Algorithmic, interaction. Self-selection bias are the cognitive bias of the users. And then you have second-order bias. What I mean by second-order bias? Well, I mean, for example, personalization, the tunnel effect, or the poor get poorer syndrome. And this is important because it's like the Truman Show. So this person learned that was living in a bubble, and he wanted to get out, but many people doesn't want to get out of their bubble. And solutions that we are using in search engines or recommended systems are diversity, novelty, serendipity. But I would like to have a new one I would call the opposite side. So let's see the person most different from me, not because I want to know what that person is doing, because I want to know how far it's from me. So I want to know the size of the universe, because I believe people is more different than we think. And another type of second-order bias, it's one of my first papers on bias in 2008 in the web conference. Let's say I'm writing a new blog page here, and I do a query to find content to fill this page. So let's say I select these 3 pieces on red, so this has some ranking bias, and I put them on the new page. Of course, I'm not cheating, so I'm not doing plagiarism, so I put a link back to the original place. I put quotes in every part, and I also mentioned the author. This is the difference between research and plagiarism. Of course, here I feel some shame, nothing mine. I put something that is mine, so this is a mashup. And then I feel some pride, so I put my name, and this is my blog, right? So what is the problem with this? The problem with this is that every time the search engine indexes this content again, it reinforces the belief that this is good content because the person selected, but selected because of ranking bias too, and not only because the content was good. So this just increases the redundancy, and the semantic redundancy may go over 30%. Today it's much more, we don't know, but in 2007, 2008 it was 30%. Sparsity. The long tail of data. You can think that if we put a data volume on the vertical axis, and all companies and institutions in the world on the horizontal axis, well, very few will have big data. Multinationals, very large companies have big data. Most of the rest will have small data. And this is the problem, because we are focusing on big data, but we're increasing the gap, the technology gap, in all the small companies that just have small data. So especially in India, please focus also in small data, not only in big data. Because small data is the real problem. And here there are some reasons why small data is important. I will not read all of them, but many times, for example, that can be understood by humans, and this is the ones that bring innovation. And here's a book of Martin Lindstrom on small data. I have an opinion in KDD Nuggets in October 2018 about small data. You can read it there. Because big data is easy, just put more data. Small data is not. So here I have an example of one of my PhD students on dyslexia screening using a web game. And it's very hard to get the data because you need people with dyslexia doing this and people without dyslexia doing it. So here you see that we did this for 2 different languages, like Spanish and English. And then we got 81% accuracy in Spanish and 90% accuracy in English. You may ask how this can be because you have more data in Spanish. Well, here is when this part about the complexity of the problem is important. The Spanish is a phonetic language, So it's more difficult to find people with dyslexia because you can use the phonetic part to compensate the problem. English is not a phonetic language, many more misspellings, and then it's easier to recognize when a person has dyslexia. That's why we have this difference. Now, remember, very important, the cost of false negatives is much higher than false positives. For example, not saying that the person has dyslexia is much worse than telling a person that it has dyslexia, goes to the specialist, and then is happy knowing that the person doesn't have it. Privacy. In 2001, so 20 years ago, Latena Sweeney, a Harvard professor, black, found that using public data, you can identify 87% of the US citizens, in spite that there is no ID in the US. And from this came the concept of anonymity. Basically, I'm hiding myself in other people that is like me. In 2006, there was a big incident that was the first time that, in spite of data being anonymous, it was possible to identify a person. This person was a woman, and this was in a AOL query log, and basically show that this may happen. Later happened with Netflix data a few years later, and recently with using data of games in cell phones. Even the New York Times identified, for example, the security people of President Trump a few years ago. This is the case of Netflix. This was in 2010. After this problem, basically the famous 1 million contest was ended. So at Yahoo Labs, when I was at Yahoo Labs, we said, okay, let's see how bad is this problem. It really was just bad luck, or is easier to predict these things? And the answer was, it's easy to predict these things. So gender, you can predict it with 84% accuracy, age, price, minus 10, 79% accuracy, even location with 35% accuracy. So the first 3 digits of the zip code. Now, how many people here has never searched his or her name on the web? All of us, we do it, right? This is vanity. So next time that you feel this vanity urge, if you want to mess with the data, switch names. You search for the name of a friend, and the friend search for your name. In that way, at least the search engine doesn't know it's you, because every time you search for your name, you are giving away your identity. And this is the reality. Partial name, 8.9%. Complete, 1.2%. The last challenge, legal and ethical issues. Many problems, like accountability, algorithms audits, ethical algorithms, what it means to be ethical if you don't think. At least maybe we can say responsible algorithms. This will be better, or algorithms for good. In 2017, so more than 4 years ago, the ACM did a statement on the 7 properties that algorithms should fulfill. These are the 7 properties. Awareness is the most important. You need to know about the problem to start doing something. Better, very important, you don't have to be perfect in a system, just better than humans. But humans are harsher on judging machines. There is a book about that, recent book called Humans Judging Machines. And then we expect them to be much better than us. And the question is, if they're learning from us, why do you want that? Is that possible? In some cases, like chess may be true, or Go, but in other cases, much harder to learn better than us because we are the teachers. So there are some hard learning problems. You need to remember that to generalize, you need to forget what you learn. For example, most systems will fail trying to recognize this animal in this picture because you don't typically take a picture of your pet under a class table. But in that case, it will be very hard to do the classification right. Also, remember, you cannot learn what is not in the data. If the data is not good, not complete, there are things that you will never learn. And the accuracy is not the most important thing. The most important thing is the impact of errors. Doesn't matter if you get 95% and 97%, if in one of your mistakes you harm people very badly. Maybe it's not ethically to apply this algorithm. And finally, be humble. If you're doing a classifier and you really don't know because the score you get or the probability of being right is small, say, I don't know. Don't give an answer. This is the best ethical way to do it. When you're not sure, say, I don't know. So here are some recommendations. For example, very important to have a code of ethics and also an ethics board. Very important, the ethics board, if it's from a company, it should be at least 50% external, because otherwise you have a conflict of interest. You can't decide the ethics by yourself if you're an institution. Also very important, we should be in control. So I prefer humans in control instead of human in the loop. The machines are in the loop. We are God. We are playing God. We are the creators. We are the teachers. We are the ones that should be always in control. Don't forget it. So I'm not really worried about artificial intelligence. I'm really worried about natural intelligence. So this is something that seems to be less and less every day. Quoting Harari in his book, 21 Lessons for the 21st Century, he says, the real problem with robots is not their AI intelligence, but the natural stupidity and cruelty of their human masters. And if we don't really realize this, we will have this other joke. So a robot goes to a computer that says, prove you're not a human. The robot says there are no more humans. The computer says correct, and they both laugh. And they are not laughing because they kill humans, because at the end, if that happens, humans kill themselves. So to end, I think the big picture is something what is coming, like more integration of things, like integration of let's say, neurotechnology with information technology, with biotechnology, with neuroscience, and this could be for good or for bad. Probably less privacy. Can we have transparent algorithms? This is complicated because if it's very ethical to be transparent, but it also means that if you know how the algorithm works, you can cheat it, and then people can game the algorithm. If we don't auto-regulate, software insurance will do. And this is my worst nightmare, because that would imply that the software will be much more expensive to do than today. Ethics for robots, remote knowledge workers. This will be the next generation of people working from home, but basically creating data to train machines. Augmented humanity, I hope not, because then that means the rich will enjoy this kind of technology and the poor will enjoy the bias of applications. So another quote from Harari, either democracy will successfully reinvent itself in a radically new form of humanity, or humanity will live in the digital dictatorships. And we are seeing things like that with the social score in China or the credit score in the US. Still, I'm an optimist. If you're living in Silicon Valley, you need to be an optimist. But you see cases of things like Philippines 2017, China 2020, Brazil in 2020, all these elections that really some people is manipulated to have their vote. I hope we are not evolving towards Solaria. If you like science fiction, Solaria is the world of a novel of Asimov called Naked Sun, where people didn't see each other and live very separate. And this will be like what's happening today now with the pandemic. But my request, if there are nice aliens out there, please come soon, so we force all the countries to talk together, for example, not only because of political reasons, but only, for example, because of the pandemic. Imagine if countries were really coordinated, the pandemic can be much better than today. So if you haven't seen the movie Arrival, that's what I'm talking about. I suggest to see that movie there. So I can take questions. This was the book that Neha mentioned, my textbook on information retrieval. and I can take biased questions. And remember, it's not about big data, it's about the right data. You need to have the right data, and that could be also a small data. So I can take questions.
Hello, sir. Yeah, that was indeed a great talk, sir. We just learned a lot of things along with the data things, and also we learned about the ethics that we have to follow in the due course of the process. I think all our participants were highly happy, very happy to look forward for your speech. So I think we will just see for the question is if anything is popped up in the chat section. I'll just ask you, and yeah.
Do you know how many people is attending right now?
So right now it's 30, in and around 40, sir. Like there were people going in and out, like they have a lot of classes also going on. So they're just managing the things in between, sir. So I'll just see if any questions pops out.
I see many good mornings, so good morning.
Very good morning, sir. Sir, I have one question personally. So we kind of, especially when it comes to languages, like say English, the pronunciations differ a lot. So like the ones in India to the US or the UK, it differs a lot. And how do you even take something as the right data when there are a lot of varieties and mutations in the language? So how do we even consider which is right and which is wrong, or how we'll deal with it, sir?
Yeah, so in the case of language is very interesting. For example, India, you have 22 official languages, so you have many. Not all of them have good natural language resources, so not all of them will have enough data to, for example, train a translator or even a parsing software. But in the case of voice, which is the case you were mentioning, so because also you have a variation between languages between different countries. So, for example, for many objects in England, they will use a word that different in Australia, different in India, or different in the US. So also they use different synonyms, but that's easy to fix with a dictionary. But when you have different accents, this is not about being right or wrong. This is about basically you need to localize the models to each location. For example, you cannot use the same model for British English, American English, or for example, English spoken in India. So maybe you can use some transfer learning to use part of the model on say Indian accent, but then you need to have some layers that are specific for your pronunciation, and maybe that may change from region to region. So maybe in Bengal with different from Tamil Nadu or from Gujarat, for example. And I did learn this for this talk. I like geography, so I already know all these things.
Thank you, sir. And one more question from one of our participants. Can you just tell us the tools that we can use to handle the big data in academics for students?
Yeah, so today there are many things like, for example, you have Jupyter notebooks, you have Google Colab, you have tools coming from Microsoft, you have things like R or Python that have plenty of libraries. So today there are many tools that are available for students to do that. You can also use things like Hadoop or even other processing platforms that even you can get, in some cases, even free time, for example, in Amazon clusters or similar. So today there's so many software that are free, that are open source. For example, Hadoop came from Yahoo, was a contribution to the work from Yahoo. In my team, when I was at Yahoo, we did Zookeeper, which is a software to distribute processes. And that's also used for many companies. It's also free. You have things like Kafka, and I can mention so many different words that are like different software. So many things. So here, there's someone that use Hadoop or relational database management systems. I think it's not a fair comparison because these are two different things, so they are not in the same class. So relational database is to store data, Hadoop is to process data. So it's different. So one is to process and another way is from a storage. However, if you want to use Hadoop, I would say that the best way to store data in Hadoop will not be, for example, relational database, but probably will be what is called a column store. So something much more simple where you can access data much faster and you can manipulate data much faster. In many cases, the fastest way to store data is raw. So you don't do anything, you don't structure. And remember that today, more than 99% of the data is not structured. You have text, you have audio, you have video. That really doesn't have a structure. The structure is implicit, it's not explicit. So a relational database will never store everything. And even if you can store this as blobs, as like a just series of bits, they are not very efficient because they take much more space. So you are wasting space.
Thank you, sir. Thanks a lot for that answer. I think you answered the next question also, which you would prefer, the Hadoop or the database management system. I would say we will just wait for a couple more minutes for the participants to ask their answer, and we will wind this up, sir. So in the meanwhile, we desperately want to collaborate with you and your research and laboratory research. So we would like to have more connection with you in future days, so that our students in our college would also be very much useful. That will be useful for them also. Yeah. So I'll contact you on that, sir, in the future. So we'll just see. Yeah, I think that is it for the day. Okay. Okay, sir. If anything else, I would redirect the questions for you over mail. So
yeah, and also my mail is available on the website. I have a website, so you can search for my name and my mail is there, and also you can follow me in Twitter. You can search me in Twitter. I always post things on technology, especially on ethics in AI, which is the current research I'm doing. So ethical AI. So there's another talk in YouTube that you can hear about ethics in AI. Also bias on the web. So there are many talks in YouTube you can hear.
That's very nice of you, sir. I believe that it's a late night in California right now, and
yeah,
thank you so much.
It's half an hour to midnight. Yes.
Oh, okay. So yeah, thanks a lot for spending so much time with us and teaching us and making us knowledgeable about this particular thing. I heartfully thank you on behalf of my ACM student chapter, our college, and personally, I would like to thank you. If anything else, I will surely redirect you with the questions, sir.
Bye-bye.
Yeah, thanks a lot, sir. Thank you. Have a good night, sir. Bye.